You don't have to. I'm not using your face, so no. And I won't say your name. All right. So yesterday we talked about if we wanted to find particular solutions, we are first going to separate the variables, meaning if there are y's, we put it with the dy. And if there are x's, we put it with the dx's. If there are no y's, we assume that y is nothing, but we can go, you'll see in a second. You still can go back. Okay, so for instance, the do you see there's not a, this is an initial, not a y in the equation. If I took the antiderivative of both sides, wouldn't you tell me that the antiderivative of dy dx is just, yeah, okay. What's the antiderivative of this? Uh-oh, would it help if I wrote it this way? Okay, let's add the power back on. So it would be x to the negative 1. But I need a correction factor. Negative 1. What's the antiderivative of x? 1/2 x squared. But I have to put a on there because now we are going to use the information that's given to you afterwards to find c. These are general antiderivative. We'll simplify this in a second. Y of 2 is 1. That means when I put in, I'm going to do this a second. You all agree with that? That negative 1 x to the negative first is the same as negative 1 over x. Okay, so when I put 2 in, that goes in for x, and this goes in for y. So to find the particular solution, I put 1 in for y, and I'm going to put 2 in for each x value. And I'm going to solve for c. So what's 2 squared? 4, right? 4 times 1/2 is 2. 2 minus 1/2 is 1 1/2. If I subtracted 1 1/2 from both sides, what would c equal? 5 or negative 1/2. So now I go back and rewrite my equation with my c. This is your particular solution. Okay, now, technically what I was doing here was I was moving the dx over here and just leaving the dy over here. Okay, so if you want to just get in the habit of doing that every time so then you're not all of a sudden thrown for a loop when you x's, that's fine. Like if you would prefer to, my first step is I could rewrite this as dy equals cosine x minus sine x dx. And so what I'm thinking then is, hey, what's the antiderivative of dy? It's just y. Ooh, let's think. I put this one on here to think, you ought to think really, really hard because we're going backwards now. Okay, so we know that this is y. Okay, what's the antiderivative of cosine? So go back. Sine. Because if you did the derivative of sine, you'd get cosine. What's the antiderivative of negative sine? Positive cosine plus c. All right. Let's put in our initial condition now. This is called the initial condition. It's giving you a specific point. Put pi in for x, y is 3, and see what we get. What is the sign at pi? Think on the unit circle. 0. What's the cosine at pi? -1. Very good. So sine at pi is 0, cosine at pi is -1. So what is c? Add 1 to both sides. Now go back to your y equals that has the c in it and put your specific in. So my particular solution is sine of x plus cosine of x plus 4. Are you getting it? Oh crap. Now, just when we were changed it.
Oh my God.
I want to find f of x. Yeah, let's just do it twice. Okay. So, work with f double prime of x and f prime of 1. Okay, would you agree the antiderivative of f double prime of x? Okay, cool. Then let's just do this. Let's just put a little integral symbol here and here. And so the antiderivative of this is f prime of x. What is the antiderivative of 12x squared plus 6x minus 4?
4x plus 3x, 4x plus c.
Whoa, you guys.
So fast.
Hold on.
No reason.
4x cubed. I'll go slow, Aiden. 4x. Do you agree when you take the derivative you get 12x squared? All right. Plus 3x squared minus 4x plus c.
I have no problem with that, just the fact that they did so fast.
You need to go home and practice your speed derivatives, Aiden. All right. Now, we have to use this one, the f prime of 1, because that's my equation. Let's put 1 in for x. 1 in for x, and f prime of 1 is 0. So I get 4 times 1 cubed plus 3 times 1 squared, 4 times 1 plus c. Well, let's see. 4 plus 3 minus 4, right? Because no matter what you raise 1 to, it's going to be 1. We got 7, 3, move it to the other side. Isn't c -3?
Yes.
All right. So that means f prime of x is 4x cubed plus 3x squared, 4x minus 3. Would you guys do it again and find f of x for me? Oh, that's so nice. 2. 2 minus 2 is 0. 0 minus 3. Ooh. It's 3. I have f of 1 is 1. Yeah. Okay, are you following? Did you get 4 for C of f? So then my f of x is x to the 4th plus x to the 3rd minus 2x squared minus 3 plus 4. Now, how does this to position, velocity, and acceleration? So let's just do one of the 2 examples. I'll do 4 having to do with that. So when we went forward, the derivative of a position function was its velocity function, correct? Of the velocity function was its acceleration. So if we go backwards, if I know the acceleration and I give you something about the velocity, we can go back and find a particular velocity. So now we can go backwards, okay? And similarly, if I know the velocity equation and I give you a particular position, you can find the specific equation. So in question 4, that's what we're doing. I give you a particle moves in a straight line and has acceleration given a of t is 6t plus 4. Find the position function given the following conditions. That the initial velocity is -6. Now, they might not write it this way, but initial velocity means v of 0, and initial displacement means s of 0. Okay. Okay, start me off. What do I do?
You did the, yeah.
What? Integral. Okay, so v of t equals v antiderivative of a of t, 3t squared plus 4t plus c. Now if they're power functions and I give you 0, that makes all the t, doesn't it? So -6 equals c. And so this is an equation then for the velocity. So then I asked for the position function, s of t. So let's take the antiderivative again. So the antiderivative of 3t squared is t cubed plus 2t minus 6t. Oops, I forgot the squared there, right? See, now technically we should do something like this. We'll call this C1 and C2 because really they're different. Or if you want to use a different variable, because we're finding C's, but it's a constant. S of 0 is 9. Oh, it happens again. That was nice of me. 0, 0, 0. This is positive 9.
All the zeros cancel out, Chase. 0 minus 0 is 0.
I put the 9 in over here, not over here.
Oh, I forgot you were recording.
You're not supposed to use names. Remember? He